If you're here, it's because you use AWS. And if you use AWS, it's almost guaranteed that at some point, sooner or later, you'll be storing your data in Amazon Simple Storage Service. S3 is a foundational service, providing flexible, scalable, and durable object storage for the cloud. And once you start putting data into the cloud, your number one priority has to be securing that data, making sure that the parties that need access have access, and no one else. We at AWS deeply understand having security as your number one priority because we think about it that way too. I'm Meg. Later you're going to hear from Becky. We both work on AWS, and this is what we think about every day. In AWS, S3 is often at the center of your workloads. S3's extreme scalability, availability, and durability make it a great place to host your business's data lake. By hosting your business's data lake on S3, you unlock more analytics, machine learning, other workloads from our AWS service offerings, our partner offerings, and your own applications that allow you to drive ever more value out of your data. So that's one way you're probably using S3. S3 is a highly available object storage, is also a highly convenient place to put all the connective tissue that make your workloads run, your configurations and things like that. And you're also probably storing your logs in S3. And these use cases are different, and they have different security objectives. So today, we're going to start with the basics. Some of you will know this already. And then there are a number of high-scale approaches to managing access in S3 that depend on your use cases and data patterns. And so we're going to give you a tour of these and talk about when you should choose each one. And we hope that you all learned something new today. All right, so let's start with what you get when you create an S3 bucket. An S3 bucket is a resource. And like all other resources in AWS, which means things that you own, at the moment you create an S3 bucket, it is owned by the account from which it was created. And at the moment it was created, it's impossible for any identity from outside that AWS account to access it. It is private by default, and it always has been. Now, S3 made 3 changes to the configurations that buckets have when you create them. These used to require customer action to opt in, and now you just get it when you create the bucket. And so we launched S3 encryption by default, which means that all new objects, both in new and existing buckets, are encrypted with AWS SSE S3, which is managed S3 encryption from S3. You get this by default unless you select another method of server-side encryption. So any compliance rules that you had that made sure that you were encrypting all your data, that's just taken care of for you now. Public access misconfigurations are made impossible by default with block public access on for all new buckets. And S3's older means of access, called access control list, abbreviated ACLs here, is off by default on new buckets. Now, we made these changes in early 2023, so anything that you've created since then has all these configurations. You can and should go back to your older buckets and turn on block public access to prevent those public misconfigurations and disable ACLs by default so that you're purely using IAM on those older buckets created before 2023. You can do that with bucket level configurations. All right, now I mentioned IAM. Let's talk about using IAM effectively with S3. And we're going to start here with the basics. So for those of you not yet familiar with how in the fundamentals IAM works, it's a really important cloud skill because practically everything else in AWS builds on it. And I realize I didn't tell you what IAM stands for. I'm sure many of you in this room know it, but it's AWS's identity system, identity and access management. And so some of you not familiar with the fundamentals yet, you'll learn this by recognizing the patterns. In IAM, users are called principals. IAM does, in fact, have users, but most modern use cases involve the role, which is an identity associated with temporary signing credentials. IAM users and roles use their credentials to sign requests to the AWS API, including the S3 API, and these are authenticated requests. Here I'm showing you 3 IAM roles with those little red worker hats. I'm going to use that throughout this presentation. Roles or principals, like buckets, are resources. Resources have policies attached to them to say what they can and can't do. Here I have 3 red policies associated with my IAM roles, and I have an example bucket in this account that has a green policy that we call a bucket policy. API requests in IAM are called actions. So let's take a look at our first policy here. I want to be able to get this object, so I'm going to use the S3 get object API. The object resides in my bucket, which here is going to be called example bucket. And the object that I want is path to object. Now, the type of policy that I want here is an allow policy. This grants access. The action that I need is the one for get action, which here is S3 get object, which is really convenient that it matches the API there. And then the resource describes what objects I can get. So here I have a wildcard object resource, which means that I can get any object in the example bucket /path/to prefix, which includes this object that I wanted. All right, a lot of times when you're trying to read objects in buckets, you also need to list them. You need to know what kind of object you're trying to get, and you need to know what exists in the bucket. I'm going to use the list objects v2 API for this one. But how do I know what to put in the action or what to put in the resource? I could guess, or I could bookmark this documentation here. This is the page for the IAM documentation for S3. We'll see sometimes it's not straightforward like get, because here we have an action that's S3 list bucket corresponding to the list objects v2. And now I know that my resource needs to be this example bucket. This documentation is really useful for when you're getting used to working with IAM and S3. All right, let's look at a little bit more complicated example. We're going to look at a policy that involves another AWS service. In this case, we're going to look at AWS KMS, which stands for Key Management System. I talked before about how we encrypt your objects automatically with SSE S3, but some customers choose to use SSE KMS, which means that the object's encrypted with a key that they own and manage themselves. KMS keys, like buckets, are resources. So here I have my same policy that says that I can get objects in this bucket. It's actually a slightly different policy because the wildcard here means that I can get all objects in this bucket. Raise your hand if you think I'm going to be able to read this object. And raise your hand if you think that I can't. All right, well, let's take a look at what's happening here. We already know that this policy allows me to read the objects in the bucket, but I haven't said anything about what I can do with this key. And we said before, keys are resources, which means that they have policies as well, instructing what we can and can't do. And so because I don't have anything saying that I can do anything with this key, my request is going to be denied here. And here we see what a policy looks like that adds on the permissions to use the KMS key. Here are the resources the KMS key earn, and the action is to be able to decrypt. Now, again, there's a corresponding KMS policy documentation page. If you really care about KMS, in order to write objects, you need the encrypt action. So lots of things to dive into here. But now I have a policy that allows me to read objects. OK, so we talked about basic policies, how to write them. Let's talk about sharing data. All the previous examples involved resources in the same account. But this picture is actually much more common. In a modern best practices AWS environment, you will use different accounts to segment workloads. This is a useful operational and security boundary, and we expect this picture to be happening a lot. But of course, that means that you may have a workload here in account ending 33 that needs to access data in account ending 66. In this example, my bucket is containing the configuration data that I need to run all my applications. And so here again, I have the same policy that we've been using for the past several slides that says I can get objects from this bucket. It's associated with my role over here in account 33. Do we think we can read this object? Raise your hand if you think yes. Raise your hand if you think no. By now you've learned that if I ask the question, the answer is no. Just because we have a policy over here in account ending 33 that says I can read objects from a bucket in account ending 66, that doesn't mean I can do that. That would be like if you could just print keys to my own house. That's not cool. So we need to say something over here in account 66. We're going to do that with our bucket policy. And we're going to allow the account ending 33 to get objects from my bucket. And so now that I've said that I can read them and the bucket agrees, we're able to see some success here on get. Now, it's likely in your modern AWS environment that you have more than 2 accounts. You could have tons, right? And you're segmenting your workloads according to our best practices. Becky is going to talk a ton about all the different ways to manage this access according to your data patterns and your data usage. But one easy thing that you can do is if you're using AWS organizations is you can use this principal org ID to say that all callers from my organization can read this bucket. It's a pretty nice simplifier if you're using orgs. All right, so we talked about granting access, but I want to spend a little bit about talking about denying access and using that to set up a data perimeter. So when we think about who needs to access your data, you can actually list it out. Your own accounts, any partner accounts that read or write to your bucket, and AWS services like Athena or Bedrock that are reading data from your bucket, and services like CloudTrail that are depositing logs into your bucket. And actually, you expect nothing else. And so if we think about this circle here as a perimeter around the access that I want to my buckets, we can use a bucket policy to write that in our policy language. And we're going to use a deny policy here. So the effect is to deny. And we are going to deny access for S3 if the request is not coming from my organization. And we can have a list of organizations here, right? So if you have partner organizations that need to access your data, you can go ahead and list them out here. And then, of course, we want AWS services to interact with our data. That's why we're using AWS. And so we're going to allow services from AWS. So together, if the caller is not from my organization and not from an AWS service, we're going to deny access. You will then need a bunch of statements allowing the types of access that you want, but this is a baseline policy that you can use to deny unexpected access. Now, we can also think about this through the lens of expected networks. You expect access to come from your VPCs or maybe your on-prem data center. And so we're going to write another deny policy here. We're going to deny access that don't come from my VPCs. And again, you can have a list if you have more than one, and that are not coming from my on-prem data center. But AWS services don't run on your networks. They run on AWS's network. And so I need a clean, scalable way to exempt AWS services from the requirement that the calls be from my network. So I'm going to use two. This first one here allows services that make calls themselves. So like from cloudtrail.amazon.aws.com. I added an extra dot in there, cloudtrail.amazon.aws.com. And the second one here handles when the service makes an onward call on my behalf, things like Athena. And so together, if the call is not coming from an AWS service and not from my network, I'm going to deny access. And then again, I'll have all my statements that grant the access that I want. And so you're probably thinking, love this. I need a data perimeter. I need it on all my buckets. But you know what? I have hundreds, thousands, tens of thousands more buckets. I don't want to spend energy or manpower auditing that every single one of them has the same deny statement in here. Well, so we just launched resource control policies a few weeks ago. If you're using AWS orgs, you can now use resource control policies to set the maximum available permissions for your resources. In this case, we're talking about buckets. You can take the deny statements that we just talked about, turn them into a resource control policy, and they will apply to all your buckets, existing and future, and you can stop auditing it. And so if you all are using organizations, I highly recommend that you check this out. This was my favorite feature launch of the year. All right, and we know that there are more issues that you need to troubleshoot and audit besides just making sure that your data perimeter policies are applied across the board. So we're going to spend a couple minutes talking about those. One of the things that we hear most from customers is that it is hard to set up a new application. I make a mistake somewhere and I get a 403 access denied. And you know what? I have no idea where that's coming from. Now I need to troubleshoot my role policy, my bucket policy, my VPC policy, and this takes hours. Well, in August, we launched additional denial source information, which provides additional information about why the access was denied. Here in this example, we have an explicit deny, which means that there is a deny statement that applies to this role that's preventing access. An implicit deny would mean that there's a lack of a allow statement. And here we're saying it's a resource-based policy in this example, a messed up by bucket policy. All right. If you have lots of buckets, you want a scalable way to audit the permissions to them. We've created a dashboard to show public buckets and buckets that are shared with external entities. We're going to take a quick look at an example here. You select Access Analyzer for S3 on this panel, select the region that you want to look at, and findings are populated. We show buckets with public access at the top and buckets with access from other AWS accounts at the bottom. We analyze your access point policy, your bucket policy, ACLs to make these findings for you. And we tell you where the policy or the ACL that's allowing access so you can go there to make changes if you need to. All right, and it's really important that you audit access for your data. You can use these in security audits, compliance audits, or just to understand your data access patterns. You can do this by enabling server access logs and AWS CloudTrail logs. You might be wondering why there are two here. Because S3 is one of our oldest service, launch access logs before CloudTrail. CloudTrail at this point has been around for about 10 years, and so we recommend that you use CloudTrail. It has all the newest features. Use server access logs if you've been using them all along, but otherwise, I think CloudTrail is probably the way to go. All right, Becky's gonna come up and talk about how we can secure structured and unstructured data in a data lake.
Advanced scalable techniques for dealing with access to data at scale in S3. But first, I'm just going to level set a little bit because there's a lot of different patterns. You know, S3 holds data, right? There's a lot of different patterns for how you might be thinking about data and access to data. So one thing to realize is that S3, somewhat unique among AWS services, although maybe not so unique, plays a dual role. So an S3 bucket is a bit of cloud infrastructure. No different from your Lambda function, from your EC2 instance. Every action on it, management actions, data actions, are all gated by IAM. So S3 here, no different than the rest of AWS. But of course, S3 is storage for data as well. Like what's in your S3 bucket actually matters for how you think about it. So what kinds of things? Well, S3 can hold any kind of data, but like, you know, generally it's going to be probably in one of these categories, right? If you have like a lot of data in S3, you have structured data, you know, that you query with SQL queries, analytics tools, machine learning. You might have just unstructured data that you organize by folder in S3. Now, you probably know there's no such thing as a folder in S3, but there are slashes. They look like folders. So we'll call those a prefix, even though you're probably thinking of them as a folder, which is a useful way to think about them. And then increasingly, you know, documents. Think about Gen AI use cases and retrieval augmented generation or RAG. Those are generally going to be documents. And this is data in S3. And actually, the way you think about your S3 bucket as your cloud infrastructure and his S3 bucket as a container for data are actually a little bit different, and both of them going on at the same time, right? Often you're going to have an S3 bucket with a big data lake in it, as well as all of these sort of cloud infrastructure use cases, all of this going on at the same time. Now, drilling, we're going to talk about the data side of this, because that's often where a lot of the scale questions come in. So I'm going to define just a few more terms: unstructured data and structured data. These mean approximately what you think. Unstructured data, anything. Structured data is, well, data with structures. Data is typically structured in tables. It's in a format like Parquet or JSON or anything else like that. For the purpose of our discussion, an important distinction here is that whereas structured data is generally accessed with SQL queries or other sorts of actions that reference the schema of the data, unstructured data, you know, the interface to that is generally your in S3 is generally your S3 get object, put object. You're sort of dealing with it on the file level, whereas access to structured data is kind of schema aware. And then finally, we're here to talk about access control. The unit of access control is actually a little bit different too. For the unstructured data, it could be the file or the folder. Like I said, these words don't really exist in S3, but that's probably how you're thinking about it. Whereas structured data, actually you have a whole schema to think about. Tables, columns, row-based access control, all of these things that actually have to do with the content and the structure of the data. different tools for the job. And actually, you can sometimes use multiple tools for different use cases simultaneously. So we're going to go through them. And my hope is that there's something here that you didn't already know about. You're going to learn something new. So I'm going to break this down into about 4 different ways to think about access to data. We'll do IAM, then we'll do more IAM. You'll see what I mean by that. And then we're going to look at use cases that are really more shaped like common data lake use cases, these kind of many to many access. And we'll talk about the tools for those jobs. So we're going to start with basic IAM approaches. Meg already showed you a bunch of these, but I'm going to do this through a data lens. So I'm going to guess that most of you have data that, in principle, you're sort of thinking about it like what you see on the screen here, right? You've got folders. I'm showing you 3 folders, red, yellow, and blue. And each folder has people who are entitled to work with it, right? Because they're working on a project, they're on some team in some group. Is this how you think about data, mostly? Yeah. And of course, there's just 3, right? You probably have more than 3. But let's start with 3, because that's easy to fit on the slide. Of course, it's common to have a few more of these, right? This was as many colors as I knew the names of, so this is what you get. But you could imagine having, well, there's actually, in an S3 bucket, there's actually no practical limit on how many of these you could have. You have as many of these as you want. It's just strings of slashes. But let's go back to 3, and let's talk about, like, how would we do that? How would we do red, yellow, and blue, each with a team that has access to it? Okay, so I'll start with bucket policies here. I could write a bucket policy like this. I could write a bucket policy that says, you remember that Meg told you that what you're looking at here lets you get all of the objects that match the blue / prefix. I did a wildcard here, and then I said that the access is for this blue IAM role. So I've arranged for the people in the blue team to be able to federate into AWS, to enter AWS as the blue role, and so now they're going to have access to the blue data. I counted the characters here, 251. Keep that number in mind. Okay. The blue team, they don't only need access to read the objects, they also need to list the objects so that they can see what's there. So we're going to add another statement here. We learned how to do that already. They're going to be able to list the bucket as long as they're listing under the prefix blue. Okay, so this is basically what the blue team needs in my bucket. Character count went up to 554. Why am I giving you these numbers? Well, because we have a little bit of math to do. Any IAM-based approach that you do in anything in AWS, particularly here, you want to be cognizant of where the limits are, right? You always want to be doing, because IAM is a control plane, meaning that there are limits on what it can represent. So here's the limits to think about if you're taking this approach. Well, the S3 bucket policy has a character limit of 20 kilobytes. So you notice that we had about 300 characters for the get object part, 300 characters for the list bucket part. If I do a little bit of math here, how many prefixes am I going to be able to talk about? Well, I'm going to be talking about 30, tens, right? Tens of prefixes. Now, if this is a scale that you fit comfortably in, because you really do only have 3 of them, this is a really good approach. It's very straightforward, just rules of the road. Rules of the road of IAM totally works for you. But where you want to start thinking about, if you're in those tens, maybe you need a different approach, right? Because you're going to be approaching a limit here. So the primary scale dimension to be thinking about is how many different folders, if you're going to be doing things directly from a bucket policy. Okay, I can get a little bit more juice out of this. Basically, what I need to do is I need to flip the paradigm here, right? Like, I get policies on buckets, I get policies on principles. So let's maybe talk about policies on principles. So back to this story, 3 folders, 3 IAM roles. Instead of writing a big combined policy on the bucket, let's write a policy specific to each role on that role. Okay, red role is a policy, yellow role is a policy, blue role is a policy. Let's look at it. The blue role policy, well, I'm not too worried about limits on the size of the policy. You can see this is pretty compact. I'm not really worried about that. You'll see it's a fairly simple policy. I give each of these a role, except I have this friend who is orange. They're on both the red team and the yellow team. In fact, their job, we pay them to join data from red and yellow. Well, red roll's not going to work for them, neither is yellow roll. We need to make them orange roll. Now, again, I've granted orange roll permission to the red stuff, permission to the yellow stuff. I'm not too worried about policy space here, except if you know a little math, you know that I just introduced a combinatorial problem, right? Number of permutations and combinations. Now, sometimes this is going to work, and sometimes it's not going to work. The limit, so you think about what would be the limiting reagent here on scale. It's going to be the number of discrete static access patterns that you're going to have in this story. The limit in IAM is 1,000. You can request a limit increase of 5,000 roles per account, but really not past that. And so what's this going to work for? This works for, like, if you have, like, 100 well-defined access patterns that you're going to funnel people into, and not a lot of sort of combinatorics on that, right? Because once you have combinatorics, you have 2 to the n. So if we're well under 1,000 discrete access patterns, different roles for the job are actually, once again, fairly straightforward and going to work pretty well. And it's when you start getting into those triple digits that's going to be a relevant limit for you. Now, so far, we've talked about just straight IAM-based. I haven't really introduced any new concepts. We've talked about just basic IAM-based approaches to this. And with all IAM-based approaches, it's good to understand these various scale dimensions. How many discrete patterns do I have? How much am I trying to represent in a different policy? And do the arithmetic on those. And, and watch as as you scale as an organization, you scale your data usage in S3, watch those numbers. So we talked about role-based access, and you might be starting to see where that fits and where it doesn't. Hold that thought on where it doesn't, because we're going to talk about the cases where, like, actually it fits pretty well, but these IAM limits are getting in your way. So you might think that the solution to this is more IAM. And in many cases, you'd be right. So we're going to actually talk about the ways to get more IAM out of S3. And there's actually really sort of 2 different things that you can do. So same IAM. One thing we could do is, instead of having each of these colors as a folder in my bucket, perhaps I could just have a different bucket for each data set. Now, this just got a lot more doable because we recently announced that you can now have 1 million S3 buckets in an account. So that's a pretty high number. So if you were able to organize your data set such that each was in its own bucket, well, you could just manage each one individually, and you'd stop caring so much about bucket policy space. It'd become a lot simpler. Each one has its own policy. You get 20 KB on this. So we have a lot more IAM to work with here. So does this work for you? Well, it might. One reason it might, so it might if you are getting sort of at the beginning of your data journey and you get to make some decisions about where your data goes, might be something to look at. It might not, right? You may have a lot of existing data in an S3 bucket organized by folder, and we have good tools for copying data en masse. It's a feature of S3 called batch operations. So if you ever did need to do this, we have a really good tool, and I recommend that you look at it. But moving data around is a drag, as well as you would need to update your applications to find the data at its new location. So if you have a lot of existing data, this approach is a little bit less practical. But this is one of our more IAM approaches. Here's the other one. It's called S3 access points. Okay. So once again, I'm going to put this all back in one data because that's where one bucket, because that's where my data happens to be. I'm going to how can I represent this? Well, I could use S3 access points. So S3 access points, a feature we've had in S3 for a couple of years. The best way to think, it's not a bucket. The best way to think about it is it's an alternative endpoint to the bucket. When you create an access point, you'll notice it gets its own DNS name. You can sort of interface with that the same way you would in S3 bucket. You are reading and writing the data at its original location. But here's the thing. The access point has its own IAM policy on it. So there's a policy on the access point, there's a policy on the S3 bucket. They both have to pass to get access to the data. But this allows you to sort of factor your policies a little bit differently. So let's say I bring out my whole crayon box and I make an access point. I leave the data where it is, but I make an access point for each of my folders. Now, you might wonder what's going on in my S3 bucket policy. Well, my S3 bucket policy, I'm going to make it really simple. I'm going to write this policy in a way that says, hey, if it's coming through one of my access points, I'm going to allow it. So basically, I've delegated the permissions over to the access points. Now, each access point has a policy, 20 KB. So now I get a lot more IAM, right? And each policy, I'm not going to be sweating too hard about how big it is. Okay, so more IAM, the data stays in place. What do you need to know here? Well, of course, because you're going to be going through an alternative endpoint to get to the data with an S3 access point, we are going to have to change our application code. The data is in a different, it's not in a different actual location, but it's in a different logical location. So your applications, so this is an application that you're looking at here. This is before I use access points. I'm just accessing the data where it is, right? So purple/rain is where it is in this bucket. I'm going to access the same exact object, but through an access point. And you'll notice that the bucket name is now this, looks like an auto-generated string. It is. It's sort of a bucket alias that's generated by S3 that means go through this access point. You'll notice it ends with the suffix -S3 alias. That's how you know what that is. But really, you use that like an S3 bucket. It'll go through the access point, evaluate its policy. And if you think about what you need to do to make this work, is your applications are going to need a way to discover or be updated to access the data at the access point instead of the bucket. But if you could do that, you get a lot more IAM. So access points, are they for you? You get up to 10,000 access points by default, so that's a pretty big number. So that's number of data sets that you can have. You can request an increase for that too. Your data gets to stay where it is. It has some nice properties on, like, you can have the S3 bucket policy focus on like guardrails, deny statements, things like that, where your policies are actually the grants. The consideration is, are you actually able to change your application code to discover the new location of the data? Okay, we talked about IAM, we talked about more IAM. Now we're going to be talking about some challenges that are actually kind of inherent to the IAM role-based access control model that we have in AWS. A lot of things fit it really well, where you can sort of define your access patterns in terms of roles. And some patterns fit it less well. It's very common in a data lake to have the need to map users to their access to data. And the way most organizations think about this, probably yours, is that you, as an employee of wherever it is that you work, you're a member of some groups probably in the directory or some other system of record. You're probably a member, if you work for a big company, you're probably a member of lots and lots and lots of groups. So you're kind of like a unique combination of different entitlements, like you and your coworker sitting next to you actually have somewhat different entitlements to data. And you need to be accessing the data that you're entitled to, but not the data you're not entitled to. And so let's do that, right? Like, we're going to build a pie chart maker. And we're going to talk about how we build it ourselves, but actually AWS analytics and machine learning services are shaped in very much the same way. So we're going to build a pie chart maker because our boss loves seeing pie charts. And we're going to build this pie chart maker. We have this data access scheme that you see up in the right-hand corner, so we got to make sure that we're enforcing this. So how are we going to build our pie chart maker? Well, a fine choice is to run it on EC2 in AWS, compute in AWS. The great thing about compute in AWS is they give you an IAM role and take care of the credentials distribution. So we'll have an IAM role associated with our EC2 instance that represents our pie chart maker application. And how are we going to get our data access? Well, if I think about it, this pie chart maker has a lot of different users, and I want each of them to be able to make pie charts out of the right sets of data. So what we're going to have to do in business logic is we're going to have to take the pie chart maker and enforce this data access scheme. Great, everybody's happy, the right people are making the right pie charts with the right data, and then the boss quits, we get a new boss who really likes bar graphs. Doesn't want pie charts, he wants bar graphs, so we're gonna make a bar graph maker instead, or in addition, because there's still some people who like pie charts too, and we're gonna build a bar graph maker. Of course, we still have to enforce this scheme of access. Hey, you know what, this time we're gonna modernize, we're gonna build it serverless. Lambda, same story though, we have an IAM role associated with the bar graph maker application, and it too is going to implement this access control mechanism. Now, most of you here are engineers, and you know that if you implement the same thing twice, you get it wrong 3 times, right? Okay, that's a bit of a problem, right? I had to do the same thing in business logic twice, meaning you can see that consistency is gonna be a challenge. Right? Mapping users to data, I had to do that in 2 places, and I'd rather just do that in 1 place. The other challenge, which is kind of related, is that the pie chart maker, as it accesses data in S3 to be able to make its pie charts, is accessing data as itself, as the application. So if I go turn on CloudTrail to S3, like Meg told you to do, like you turn on your data events, and you take a look at who accessed an object in S3, you will get a completely correct response, which is that the pie chart maker application role accessed your object. But that didn't actually directly answer your question, did it? You wanted to know who was looking at that pie chart, right? And that context doesn't carry through. You get, now of course, there are many solutions to this problem in traditional AWS. You just need to have the right records of who was using it and connect all of the dots. But you would actually prefer, here we have the Magenta user creating a pie chart. We'd actually like some record in CloudTrail that was who was sponsoring this data access. So that's a bit of a challenge. So these are 2 twin challenges in these many-to-many, not so role-based access control scenarios in S3. We have 2 paths to solve that problem. One is S3 access grants. That's when your data is unstructured. We have S3 access grants. We have lake formation. These are sort of the 2 approaches to doing this. And which one you use depends on what kind of data you have. Unstructured data through S3 access grant, structured data to lake formation. There's actually nothing preventing you from using both simultaneously because some use cases regard the same data as unstructured and some regard it as structured, but we'll talk about these as 2 discrete approaches. Now remember, unstructured means your pattern is file by file, get object, put object, not so concerned with the contents of the objects. Structured data is very concerned with the contents of the objects, with the schema, and the units of access control are tables and columns. So we have these 2 different approaches. For unstructured data, we're going to talk about S3 access grants. S3 access grants launched about a year ago. We're going to also talk about lake formation. Both of these, notably, support user identity directly with an integration with our IAM Identity Center service. This is the same service that many of you use to configure account access for your workforce. This is actually a different category of functionality. This is taking those identities that you synchronized into AWS and propagating them all the way down to our data systems, like S3, like lake formation. So this we launched about a year ago, so it's relatively new. So first, let's talk about S3 access grants and what you can do with that and kind of how this solves your many-to-many problem. So I'm showing you an example of S3 access grants because this is the easiest way to understand it. Once you look at these, you'll understand what's going on. The unit of access here is prefix in S3, so kind of folder. The levels of access are very simple, just read, write, read, write. So kind of a simplified access level. And then you notice the grantee. This is what I mentioned about the identity center integration. The grantee is actually a directory group. Like back from if you're using Entra ID or Okta, you're pointing to a group back in there. What that means is that as users leave and join groups, move around your organization, their permissions just update. You're not like dealing with some sort of mapping system in the middle, right? So this is really good. Now, so this is S3 access grants. So how does this solve our problem, this approach? Well, let's go back to our pie chart maker and our bar graph maker. Remember, we were stuck implementing the access scheme twice. We didn't like that. And S3 access grants actually solves this because instead of defining and enforcing this scheme in two places, now it's just an S3 access grants, and we've updated both our pie chart maker and our bar graph maker to integrate with S3 access grants. I'm going to show you the details of that in just a second. And now I have the access gate implemented once. Furthermore, when they go through this access gate, the user's identity, this feature is called Trusted Identity Propagation in Identity Center. It's a primitive. Think of it as similar to OAuth. The user's identity goes all the way back to S3. If you look at the CloudTrail for S3, you will see a user identifier, a GUID, that points you back to the user. So you will see that the Magenta user accesses. So this is S3 access grants and lake formation, like we'll see in a minute, solves these many-to-many, these two twin challenges of many-to-many access. Okay, so how does this actually work? It's useful to know how this is going to work if you're going to be building on top of it. Okay, so let's talk about accessing an object in S3 before access grants. So here I've got my data application. You'll see I'm doing a get object. Again, there's a bucket. There's a key to the object. This is how I act. Now, with S3 access grants, the dance is going to be a little bit different. Because first, I no longer have my pie chart maker application no longer has standing access to all of the data. It actually is going to take an authenticated session from the user, first go to access grants as sort of the authorization gate, as sort of a policy decision point, and then only if it's allowed in, the success response from S3 access grants is going to be a temporary IAM session, and then it's going to go access the data with that, the temporary IAM session with the user's identity baked in. So what you just heard is that it's a slightly different choreography to get to my data in S3 with S3 access grants. So that does mean that we're going to have changes to our application, but we've actually done some work in our AWS SDKs, particularly in Java and Boto 3 Python. We've done some work to sort of make that easier. If you're using a different programming language, that doesn't stop you from using S3 access grants. It's just you're going to have to write the 4 or so lines of code for this initialization sequence. But the changes are all in the initialization sequence of the client. Basically, I'm showing you here our Boto plugin. So there's a plugin that you install for Boto. It's S3 access grants aware. You instantiate the S3 client with that, and then under the hood, it's doing that dance. It's doing that dance with S3. So that's how that works. You can look at how that all hangs together, but this is how you would build an app on top of S3 access grants. But you know what? You don't even need to do that. This year at reInvent, we launched, this was out of our transfer family application. So this is the area of AWS that offers functionality like manage SFTP. But this is a feature that's actually directly relevant to S3 access grants. I can define some grants in S3 access grants, with the identity integration. And I can go to transfer family web apps. And with one click, I can request that just a very basic application gets generated around my access grants. So my users are going to go, I'll have a URL for them to visit. They'll go to the URL. They'll get sent to SSO with your directory. And this is a purple user has signed in. My purple user's in the blue group and the red group, of course. And so he's entitled to the blue folder and the red folder, so that's what he's seeing. If he logged out and the blue user logged in, he'd just see the blue folder, right? This is actually really, really useful. Solves a problem that you probably have but may have never thought about. You know how S3 is a really convenient way to share data and collaborate with people on data, like somebody uploads something, somebody downloads something. And today you have to, even if the person you're collaborating with isn't necessarily an AWS cloud operator, you need to tell them, you go into the AWS console and go find S3 and use that UX for upload. They don't need to do that anymore. You could make a transfer family web app. They'll SSO to it the way they're used to SSOing into single sign-on to any corporate application. And they'll get this very basic, they'll be able to upload their stuff. They'll be able to download this stuff. This is the most basic S3 access grants application, and we built it for you. It's built on S3 Object Browser, which is an open source UI component. So if you don't quite want us to build the application, but if you want hosted UI around S3 uploads and downloads, or you want to build your own UX around S3 uploads and downloads, I would look at S3 Object Browser. It's a reusable component that we've open sourced. Okay, S3 access grants. Is this what you need? Well, S3 access grants goes to very high numbers, 100,000 by default. It also solves that problem of having to define these, when you have these many-to-many mappings, having to define them in many different places and having these roles in the middle that lose audit context along the way. It solves all of these problems. And the only thing to think about here, so this is when you have data lake use cases with unstructured data, that means use cases that are going to access the data object by object. This is a really good choice. The only consideration here is that, as I showed you, you will need to update at least the client initialization sequence of your applications. You don't need to update the part that's actually doing stuff in S3, but you do need to update the initialization sequence, either using the plugin if you're in Java or Python, or by writing a few lines of code yourself. But if you have the ability to do that, it's really going to give you a much better end-to-end access and audit story at scale in S3. Okay, now the dual of S3 access grants, when we're talking about structured data, tables, columns, rows, anything with a schema, is going to be AWS Lake Formation. So I just moved up one level of the stack in AWS. AWS Lake Formation, if you haven't heard of it, is very closely connected to the Glue data catalog in AWS. So this is our analytics data catalog. It's our metastore for structured data in AWS. So the Glue data catalog is a catalog of all of the data that you have in S3, Redshift, a bunch of other places in AWS. Lake Formation is actually part of the Glue data catalog. It's the permission system for the Glue data catalog. Because permissions, if you're talking about structured data, needs to be able to refer to the schema of the data. So you can't quite do that at S3. It doesn't know about schema. You got to do it up at the metadata layer. Because in S3, an object is an object. So I have it seems I have structured data in S3 here. If you work with analytics, you know that what I'm showing you are names of Parquet files. So you can see it's probably have structured data in here, but S3 doesn't know that. S3 just knows that I have these objects with these names. So I could go and dump this out. We'll make it a CSV to make it easier to look at. Clearly, I have a table here of some kind, right? I got a header, I've got columns. In fact, I'm going to draw that out as a table. So let's look at that here. And if I think about permissions, right? I clearly have some kind of table here of people in their geographic locations and some sort of transaction that happened and the price. I might actually, depending on how sensitive these different columns are, I might have opinions about different users of my data being able to see different parts of the table. And that means different parts inside. You notice there's all in that S3 object. So you need to see different views of the data in that S3 bucket. So I might have an administrative user is allowed to see everything. So when they do select star, they see all the columns. But I may have other users who I actually don't want to show the geographic location. Maybe I consider that sensitive data. So when they do select star, I wanted to show them the stuff they have access to. Okay, so we just spent a lot of time on IAM, so let's try to figure this one out. So how do we do that with S3? Well, let's start writing a policy. Get object, of course. I know where the objects are located in S3. What condition would I write to make it so this guy does select star and sees everything, and that one says select star. Meg, is there an IAM? Meg says no. Meg says we can't do this. And she is right because neither IAM nor S3 knows what a column is. S3 doesn't know what a column is because S3 knows what an object is. IAM doesn't know what it is because IAM actually has nothing to say. IAM is on a very sort of literal and pedantic level. IAM is, can you make this request? Once it says yes, it has nothing to say about what you get back. So IAM has nothing to say about it either. So what do? Well, this is why it has to be up at the Glue level. So we clearly need something that is going to let us talk about the schema, and that is exactly what lake formation is. So here I'm showing you a very, very simple example of some lake formation grants. And you'll notice that for my sum data user, who only got to see those two columns, I actually gave them column level permissions. I didn't give them permission to all of the columns. Okay, so Wondering, S3 can't do it, IAM can't do it. How does this work? Well, of course, the analytics engine in the middle needs to be helping out here, right? So how does this work? Let's say I do this query through Athena. Select star from these listings. Well, Athena, think about how the Athena query engine must work. Well, first it's got to go to the Glue data catalog, get some schema. Glue is integrated with lake formation, so it knows what columns to even tell me that are there based on who's asking. So we go get the metadata from Glue. We go to lake formation to ask, well, we need to read the data. Glue has told us the S3 data is here, and so we go to lake formation to get access to it. If this sounds a little bit like S3 access grants, it is very similar. Lake formation makes a decision, and S3, Athena now has the ability to read the data from S3. Of course, S3 still doesn't know your columns, so all the data is getting sent back to Athena. It's Athena doing the filtering, right? Athena has gotten a filtering directive back from lake formation. So it requires a little bit more integration because it's not till we get to the compute engine that we actually even have the ability to filter things out. So that's how it works. Okay, should you use lake formation? This one's a pretty easy one to answer. If you're using structured data in AWS, using anything in our analytics world, yeah, you should use lake formation. You should have the data catalog in the Glue data catalog, and there's a bunch of extensibility for different kinds of connectors there. But the basic scenarios, like what I told you, are quite straightforward. If you have structured data, you should definitely learn about the Glue data catalog, because this is what enables you to be powerful with permissions and a lot of other, ETL and a lot of other functionality in the analytics ecosystem. So, and then if you're doing that, lake formation, which is integrated with identity, meaning you can express, the lake formation grants I was showing you weren't referring to users and groups in the directory, they were referring to IAM principles, but you can also, like I show you in S3 access grants, refer to users and groups. So you can make these grants in terms of, this group has permission to this table, but not these columns. You can write those kinds of grants. And our analytics engines are integrated with that and will enforce it for you. So that gives you kind of a good sort of end-to-end identity story for anything doing analytics. Wow. Okay, so that's 4 different ways, and I hope one of these was news to you. And really, a lot of this depends on actually what your scale numbers are and what the shape of your access is. If you have these static, role-based approaches, even ones that sort of seem to outstrip the scale of IAM as it is, we have IAM approaches for small to moderate scale, and then we have the more IAM approaches when your IAM is the right fit, you just need more of it, more buckets, more access points. And then we talked about when your shape is actually not role-based, when it's many-to-many, when it looks like a data lake. We talked about S3 access grants for unstructured data, lake formation for structured data. So that's what we did today. We started with the really basic stuff, the ways in which S3 is already secure for you by default, and you didn't even need to come to this talk because we already did it for you. Then we talked a little bit about, getting up to speed on IAM and S3 and really how it works from first principles. And then finally, I gave you sort of 4 different ways to think about advanced access control, including fine-grained access control to S3 at scale. And hopefully you'll find that one of those fits your use case pretty well. Wow, reInvent Thursday, right? Okay, well, I hope you had a great week here at reInvent today. I hope you have a great rest of the week, rest of today and the party tonight. Thank you so much for coming, and good luck with your data access.